All right, welcome back to 5.2, where we're learning where the electrons are arranged around the atom. In the first podcast of this section, we were talking about the fact that electrons are going to be arranged around the nucleus in such a way where they can maximize their attraction to the nucleus, but yet minimize the repulsion. And so they follow three rules as they fill these orbitals. They follow the Aufbau principle, which says that they have to start as close to the nucleus as possible, the lowest energy level, and then they work their way further and further away from the nucleus, and hopefully that makes sense. The second rule is called the Pauli exclusion principle, which simply says that two electrons can fit in an orbital at the same time, one spinning up and one spinning down. And so they have to fill that orbital before moving on to an outer orbital. And then finally, Hund's rule simply says that when you get to an orbital that has equal energy, such as the 2p's, you have three different 2p orbitals, you got to put one electron in each first before going back and pairing them up. All right. Some people call that the kindergarten cookie rule, because each orbital has to get an electron or a cookie before they get their second helping. Right? But once that's filled, then you got to move on to the next lowest energy level, or the next lowest orbital, and fill that before moving on to the next one. So let's take a look at an atom here, and hopefully this makes sense. Hydrogen. Hydrogen is the first element, and it only has one electron. So where is that one electron going to be placed? It's going to be placed in the 1s orbital. That's the closest, the orbital that's closest to the nucleus. And so its electron configuration is simply going to be 1s1. You have one electron in the 1s orbital. And so that's its electron configuration. Now, helium, if you're looking at your periodic table, and you should have your periodic table in front of you. If you don't, pause the podcast, get a periodic table, because this is how you can make these predictions. Helium, being the second element, has two electrons. So you're going to put the first electron in the 1s, and now remember, you can fit two electrons in an orbital, so we're going to put the second electron also in the 1s orbital, and so its electron configuration will be a 1s2. You have two electrons in the 1s orbital. And so that's its electron configuration. Moving on. Now, by the way, if you notice, hydrogen and helium are in the first row of the periodic table. They're the only elements that are in the first row. That first row indicates that electrons are filling the first energy level. All right? But when you go to the next element, which is lithium, notice you're in the second row of the periodic table, which means you're going to be filling the second energy level. Okay, this is the 1s, the 2s, the 2p's. Don't worry about the other ones. We won't get to those quite yet anyway. So lithium, having three electrons, you're going to place the first one in the lowest energy level. You're going to place the second one in the lowest energy level, and now that's filled. So you have to go on to the next lowest energy level, or the next lowest energy orbital, which would be the 2s. So we're going to put the last electron in that 2s orbital. Its electron configuration then is 1s2. You have two electrons in the 1s orbital, 2s1. So lithium's electron configuration is 1s2, 2s1. Let's try beryllium. Beryllium is the fourth element. It has four electrons. You're going to put 1, 2 in the 1s. You're going to put 1, 2, the third and the fourth electron in the 2s. Now you're out of electrons. Beryllium's electron configuration is a 1s2, 2s2. All right? Maybe you see the pattern here. Let's go down to boron. Boron has 5 electrons. So you're going to put 1, 2 in the 1s. You're going to put 3, 4 in the 2s. You have one more electron, so you have to go to the next orbital. You put the fifth electron in the 2p's. Okay, again, this is the 1s, 2s, and these are the 2p's. So the electron configuration for boron is going to be a 1s2, 2s2, 2p1. You have 2 electrons in the 1s, you have 2 electrons in the 2s, you only have 1 electron in the 2p, and you have a total of 5 electrons. Moving on to carbon. Carbon is the sixth element. It has 6 electrons. And so you have to put 1. Oops, excuse me here. You have to put 1. And by the way, I'm going to start cutting these arrowheads in half. Instead of drawing a full arrowhead, I just draw them as hooks. So you have 1, 2 electrons in the 1s. You have 3, 4. Now you have those in the 2s. You have 2 more electrons left. Now remember, Hund's rule says that you have to put 1 in each before you go back and pairing up. So now you have a 2s2, 2p2, 1s2, 2s2, 2p2 electron configuration for carbon. You have 2 electrons in the 1s, 2 electrons in the 2s, and you have 2 electrons in the 2p's. When you get to nitrogen, nitrogen has 7 electrons. So you have 1, 2, 3, 4, 5, 6, 7 electrons arranged that way, and the electron configuration is going to be a 1s2, 2s2, 2p3. Okay, scrolling down here. With oxygen, oxygen has a total of 8 electrons, so you have 1, 2, 3, 4, 5, 6, 7, 1 in each. Now you have 1 more, so you go back and pair it up. 8. So oxygen's electron configuration is going to be a 1s2, 2s2, 2p4. This is not, some people want to put a 2p2, 2p1, 2p1, but that's not the case. This is all considered one orbital, and so you have 4 electrons in it. So it's a 1s2, 2s2, 2p4. Okay? Go ahead and try, if you want to pause this, go ahead and try fluorine and neon on your own, and then go ahead and unpause it, and I'll walk you through it. Alright, so let's go ahead and try fluorine and neon now. Maybe you've tried this already. Fluorine has 9 electrons, so it has to go 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons for a total of 1s2, 2s2, 2p5. Alright, and then finally neon. Neon has 10 electrons. 1, 2 in the 1s, 3, 4, that goes in the 2s, 5, 6, 7, 8, 9, 10. And so now you have a 1s2, 2s2, 2p6. And now the second energy level is actually filled. There are no more orbitals in the second energy level. I'm just going to kind of pause just for a second here and explain something. I'm going to do this off to the side. As it turns out, now again, we're talking about where these electrons are located around the nucleus. As it turns out, in the first energy level, there's only one sublevel. So this is the energy level. You have these sublevels or orbitals. The first energy level only has one. It has the s orbital. The second energy level has 2 sublevels. It has s and p. The third energy level has 3 sublevels, the s, the p's, and the d. The fourth energy level has 4 sublevels, the s, the p, the d, and the f. Now technically the fifth energy level has 5 sublevels, the sixth energy level has 6 sublevels, but we never get to those. The f is the last sublevel that we actually get to. Alright? So the second energy level only has s and p orbitals. So now that is completely filled with neon. Neon uses up all of the first and all of the second energy levels. So when you get to the next element, element number 11, which is sodium, you have to start filling the third energy level. Because you're filling the third energy level, it drops down to the third row of the periodic table. And you have to start filling the 3s, but the third energy level will have 3 sublevels. It's going to have the s, the p's, and the d's. And in the next podcast, we're going to walk you through filling that third energy level.